Okay, great. Yeah, thanks, Emily. And yeah, thanks everyone for coming today. Welcome to the MaterialX and OpenPBR Town Hall, which is part of the virtual town hall series from the Academy Software Foundation. Let me get my slides happening. So this is the lineup we have for today. This is a really cool series of presentations. I'll give just some quick updates at the top about work that's happened on the MaterialX project itself. And then we'll hand it over to Adrien, Herubel, and Peter Kutz to talk about updates to the OpenPBR project, one of the biggest things that's happened in the past year. Then Karen Lucknavalai from Pixar will talk about MaterialX in OpenUSD and Hydra, followed by Frankie Liu from NVIDIA, giving an update on MaterialX and OpenPBR in Omniverse. And then Nikola, Milosevic, and Gunnarsson from Autodesk will give updates on LookdevX and the latest version of Maya. And then Mihail Djurev from Chaos, for the first time, will be presenting on MaterialX and V-Ray. And then we'll wrap it up with Rydalch from SideFX talking about the latest work on MaterialX in Houdini 20.5. So I'll just go quickly through some updates for the MaterialX project in the past year. One of the big events at the end of 2023 was the release of MaterialX 1.38.8, which was a big one for us. Autodesk and SideFX contributed a large new set of pattern nodes, and you can see some of those rendering in the Houdini render on the right. Apple contributed the first support for MaterialX on the iOS platform, I think now integrated into iOS 18. And we added support for MaterialX Python installation through the Python package index, something people had been asking for a long time. So you can just type pip install MaterialX on the command line and get the latest version. And then on the rendering side, we improved the accuracy and the performance of GGX importance sampling in real-time shading, specifically integrating a paper from Dupuy and Benyu from HPG 2023. Another big event near the end of 2023 was ASWF Dev Days. This was the first year that this event happened. It's where ASWF projects provide dedicated mentorship to new contributors over a period of 2 days. This event was a huge success for a lot of projects. We had 14 new MaterialX contributors, including new university graduates, but also developers from companies like Weta, ILM, and Autodesk. And we're going to have a second one this year. It'll be happening in September. And I've provided a link down at the bottom for folks that want to join us in that and receive mentorship on MaterialX or any other project. Another big event from last year was the launch of the Alliance for OpenUSD. This is an initiative that is focused on developing a normative specification for USD. And this year we formed a materials working group within that, chaired by myself and Anders Langland at NVIDIA. And this new group will be focused on the integration of MaterialX into USD. There's a lot of work to be done there. We're interested in contributions from folks in the industry, and you can check out the link down below for details on that. Then finally, a big event now just from, I think, 3 weeks ago, very recent, is the release of MaterialX 1.39.0. This was a huge upgrade with improvements to both the specification and the code base for MaterialX. Sort of one of the top line improvements is this is the first version of MaterialX with support for the OpenPBR surface shading model, a project that we've been working on collaboratively with a bunch of companies in the industry and that we're very proud of. And then supporting that, there are some major improvements to the physically based shading nodes in MaterialX, especially some new functionality based on new work in the industry, and so also improvements to the pattern nodes, filling out some of the missing details that integrations of MaterialX had run into to make a more complete standard. Also, there were some significant optimizations to real-time shading in this release. We're finding speed improvements with a 2-to-1 frame rate improvement in many cases. There's still more work to be done and improvements to real-time shading, but we feel this is a really significant step forward. And then finally, I'll just say here's some links where you can join the conversation about MaterialX in particular. We have a link to our front page, materialx.org, ASWF Get Involved. You can join our ASWF Slack and mailing lists there. And then finally, Dev Days 24 will be happening later this year. And with that, I will hand it over to Adrien Herubel and Peter Kutz to talk about OpenPBR. A lot of cool updates there.
Hey, thank you, Jonathan, for the introduction. So, hi all, I'm Adrien. I'm the dev manager for Arnold at Autodesk, and today with Peter from Adobe, we'll give an update on the OpenPBR project. So we'll present the state of the OpenPBR project, show off new features, report on the state of integrations and products, and discuss the future of the project. As a quick reminder, the project started as an attempt of merging Autodesk Standard Surface and Adobe Standard Material. Autodesk and Adobe share a large user base, so it made sense to facilitate the exchange of assets between our tools and by attempting to merge both our standards together. When the conversation started with Adobe, we set out with clear goals. We wanted to build a physically based model, one that is artist-friendly, as our users don't just consume materials, they author them. A model that satisfies the need of the media entertainment industry and practical for real time. And we wanted to have an open governance for the project, as it should not be controlled by a single party. So here's a condensed timeline of the project. And the first step, obviously, was a team from Autodesk discussing with a team from Adobe, going over both specifications line by line, looking at what was in one standard and not in the other, what was in both, but behaving slightly differently, and really trying to find common ground. And very quickly, we identified things we loved in standard material, things they loved in standard surface, and became clear that yes, there was a path towards alignment. So after a few months of back and forth, we started to write the specification, and we then brought in the Academy Software Foundation to achieve the open governance goal in June last year. And the project was officially put under the MaterialX project. So we did a round of reviews privately with software and hardware vendors, as well as studios. And we then announced publicly the project at SIGGRAPH last year. And the in-progress model was made public in October. And here we are now. The version 1.0 of the model was released last month. And let's talk about the outcomes of the project. So we now have a finalized specification for a surface appearance model that is unifying Autodesk Standard Surface and Adobe Standard Material with a few key enhancements, which we'll present later. We have a MaterialX reference implementation, which is expected to render in MaterialX-enabled tools once they upgrade to the newest version. The project has an open governance under the Academy Software Foundation as a sub-project of MaterialX. And there's major interest from vendors, as you will see, for supporting it, and from end users as well, as they very much see the value in the project. And now to introduce the new features we added to the specification since we made it public last year, I will hand it over to Peter.
All right, thanks, Adrien. Great, so I'm going to discuss some of the new features and some of the notable features in OpenPBR. A lot has changed and developed since last year. First, we have one of the main principles of OpenPBR is energy conservation. And to that end, we've actually introduced a brand new rough diffuse reflectance model. And this is based on the Air model, but perfectly conserves energy. Here you can see on the left, we have the smooth version, and on the right, we have rough. I'll show you a few more angles here. Here on the left, you can see the roughness changing, and on the right, you can see the new energy-preserving Air model compared to the qualitative Air model that's used currently in MaterialX and many other tools. And to really show you what's happening, here are some white furnace renders. The only reason that the new version on the right has any darkening is just the limited bounce count. But you can see it passes the white furnace test, and on the left, the old model does not. And even the full RNI model, which is based on 2 bounces of microfacet multiple scattering, doesn't pass the white furnace test. So this new model is energy conserving and efficient. And it still preserves the nice features of rough microfacet models like RNI by giving you, for example, this really nice flat retro reflection when the surface is rough, that you can see on the right here compared to smooth or Langbertian on the left. We also have a new fuzz model, which is based on the Zeltner 2022 Disney LTC Sheen paper. And this is actually based on a microflake volumetric scattering model. And it actually models microflake multiple scattering, not just a single bounce. It's fitted with linearly transformed cosines. So it offers perfect importance sampling and relatively efficient evaluation. And it really improves the range over a lot of existing Sheen or fuzz microfacet models. So here you can see the roughness changing on the right. And here you can see the range of roughness values comparing the new Sheen on the top with the old Sheen that is commonly used in many material models on the bottom, the SPI Sheen. Another feature is some improved coat darkening. So when you have a coat over a surface, in reality, it should darken the surface due to internal reflection from the inside of the coat and reabsorption events on the base surface. And now we simulate that we offer formulas actually to simulate that more accurately. And it's an opt-out feature. So it's on by default. By default, the coat may darken the underlying surface, saturate the underlying surface, but you can opt out and get a more slightly more art directable look if you want to. So here's an example of that parameter being modified from 1 to 0 and back. And here's some other images that show the different values of that coat darkening parameter. Another cool feature is in the area of transmission, specifically dispersion. So it's very common to see the Abbe number offered in material models where you can physically set the amount of dispersion that you get. But the Abbe number is very unintuitive. The range of values is very unintuitive. It's inverted, so higher numbers mean less dispersion. It's very confusing, especially for beginners. So for everyone really. So we have actually, in addition to the Abbe number, we have a dispersion scale parameter now that allows you to scale the amount of dispersion linearly. And you can see the effect of that here. So 1 in the center means that you have a normal amount of dispersion corresponding to your most extreme Abbe number. And then you can scale it down to nothing to get no dispersion, or you can even scale it up to get additional dispersion. So you get more of those rainbows and a nice prism effect and that kind of thing. We also, I think we also mentioned this last year, we actually have a new expressive layer ordering. So we have a fixed order of layers in OpenPBR to keep things really simple and transferable between different software and everything. But we've reordered the layers to be a little more powerful. So you've got the emission on the bottom, you've got the base surface, then you've got the coat, and then you have the fuzz on top. So here you can see how you can actually use the fuzz now on top of any other material properties to give you this nice like dusty appearance, which is especially nice when you couple that with the new Sheen model, which looks pretty dusty at high roughness especially. And in addition, we may have mentioned this before too, we have a new metal model that offers a lot of the same benefits. It's physically based conceptually, but it's also more art directable. So the color you put in for the incident direction and the edge color of the metal, you'll really see reflected really nicely in your render. So on the right, you can see the new model. and how the two colors from the upper left of this image are nicely shown in that metal. And in addition, you'll find if you look at the specification, we have a lot of new user-friendly tweaks, making things more intuitive, more physically based, simpler, more streamlined. For example, we have a new thin film parameterization for that those interference effects and more natural specular weights for something you do every day. Modify the amount of specular, and it's a little more straightforward and intuitive now. So now I'll pass it back to Adrien to discuss how we're integrating OpenPBR and how others in the industry are integrating OpenPBR into other products and applications.
Thank you, Peter. Great showcase. So this specification was written for implementers, making it possible to go from the formal slab model that is described there and the operation tree to a mixture of loops that can be implemented in a renderer. And we have quite a few integrations underway, so let's do a quick review. The reference implementation of OpenPBR is in MaterialX 1.39, and it will be the basis of many of the OpenPBR integrations. USD and MaterialX enabled DCCs are now on the path towards upgrading to 1.39, though it might take a little while to do. In the meantime, building and using MaterialX 1.39 is an easy way to test OpenPBR right now. Peter, you want to do the honor for the Adobe integration?
Sure, yeah. At Adobe, we're working to integrate OpenPBR into multiple Substance 3D tools, and there are different stages of implementation, but stay tuned. And we're also working on like various assets to test this and to showcase OpenPBR. So yeah, stay tuned.
And for Arnold, the next version of Arnold, which should ship very soon, will support OpenPBR natively. And here you can see a version of the OpenPBR playground rendered with Arnold. And this will bring OpenPBR support to any DCC supporting Arnold, such as Katana, Cinema 4D, Houdini, Maya, and 3ds Max. And speaking of which, we are actively working on native OpenPBR support in Maya. And we also want to support OpenPBR natively in 3ds Max. And here's a quick preview of the OpenPBR integration in NVIDIA Omniverse. More details on that in Frankie's presentation later. Here's the warehouse scene from the recent Houdini launch, rendered with Karma. It was modified and re-rendered using an internal build of Houdini with OpenPBR, and will be available in a future release of Houdini. So that was a sneak peek of integrations, and as you can see, the focus of the OpenPBR project is now to help increase the adoption of OpenPBR and support implementers. We are continuously reviewing feedback and looking into new ideas, and everybody from this group is very much welcome to contribute. The specification is not frozen in time, as shown by the recent 1.1 release containing a few bug fixes and small changes. And the MaterialX team has been working on adding shader translation graphs from and to standard surface to increase the compatibility of assets all over the place. And something that is very important for us is that we want to extend OpenPBR beyond surfaces. And this is really a call to action there. We want to look into specifying full appearance models for volumes and for hair. And that's it for me. I will then pass it on to Karen, I believe.
Hi, I'm Karen. I'm from Pixar, and I work on the MaterialX integration into USD and Hydra, and I'm talking about the improvements that have happened over this past year. So the most recent changes that have gone into that are currently in the dev branch include support for MaterialX version 1.38.10, as well as some additional Vulkan shader gen support. So now when you use USD View, and Storm, you can use either OpenGL, Metal, or Vulkan for all your rendering needs. And the image on the right actually is rendered with Vulkan. We also had a couple corrections to the material tag detection, specifically for GLTF and OpenPBR materials. There's also an additional MaterialX and Hydra and USD developer guide that is up and available. You can find that under the developer guides on OpenUSD's API documentation website. There were a couple of smaller changes that are in that latest dev branch, including a fix for handling triplanar projection nodes and a couple other smaller things. A larger change that has gone in is a significant improvement for Storm's shader caching. Last year, I showed the image on the right to highlight the initial caching that was available, and it was pretty limited to just the simple materials that you can see here. There are ones that are just the standard surface or preview surface or whatever type of material, no node graph or anything like that. But now, thanks to a pull request from Autodesk, we're able to cache a lot more complicated materials, including, of course, ones with node graphs. And anytime you have two materials that are topologically the same, you'll be able to get those caching benefits. So in this example, I have 3 materials, all topologically the same, and they're all getting to share that same shader. And you can see on the right, we have a nice speed improvement there. Some other changes that have gone in this past year include color space support for within HD, MaterialX, and Storm. So you can see in the example on the right, we're using both sRGB and LinRec 709 there in a couple different ways. So just like you would in a regular MaterialX file, you can have a global color space or specify a color space on any particular input. Obviously, for textures, it works exactly as you want it to as well. Please note that this is support for just the MaterialX pathway. Full color space support within all of USD is still in progress. The current goal that I'm aware of is to have that go in around the fall. Additionally, we have some updates to the imaging tests that are all open source. So hopefully our outside contributors will have a much better test suite so that they can run any changes they want to test against. There were also a couple of normal map fixes in both Storm and PRMan. You can actually see the test case for the normal map in Storm on the right here with the normal map versions on the bottom with the reference geometry on top and the MaterialX implementations on the center and right. So luckily they all look the same, which is what we want. Some other various bug fixes have gone in this past year include name collision. We had a name collision issue with like inputs and built-in uniforms within Storm. That's no longer an issue. There was a fix for OIT when using Metal and MaterialX. Shader compile issue with height normal nodes. And there was improper, the file prefix wasn't being added to the file names appropriately, which all these are fixed now. And they're all thanks to pull requests and Git issues that were made by outside contributors. So as always, when you're playing around with MaterialX and your USD scenes, and you notice something wrong or have a wouldn't it be great if moment, please make a Git issue or even better yet, a pull request, and we can get that incorporated. On the PRMan side, again, we had that normal map fix and also a couple of more special case fixes. For one was a case that you had say one node being used in multiple places within your node graph and material, that the shader wasn't being generated appropriately, all fixed now. Search path determination is fixed as well. And that's all I'm going to say on the RenderMan and MaterialX side. If you want more information about that, there's an OSL virtual town hall later today where a couple of my fellow Pixarians are going to be talking about OSL and how it's central to the RenderMan XPU. And there's a bunch of work going on there that's going to help pave the way for MaterialX and OpenPBR support. So if you're interested in learning more about that, virtual town hall is later today at 4 p.m. Denver time. If you're curious about other updates about just USD or Hydra in general, there's of course a BOF at SIGGRAPH a week from tomorrow that please come to for all those information. That is all the updates on my end, so I'm going to hand it off to Frankie with NVIDIA.
Hello, everyone. Hi, my name is Frankie Liu from NVIDIA, and I'll be sharing our latest work on material exchange with MaterialX. NVIDIA Omniverse is a platform of APIs and SDKs designed to enable developers to accelerate industrial digitalization workflows based on OpenUSD. Our platform is used in a wide range of areas, from autonomous vehicles and robotics to performance and industrial optimizations through simulations using digital twins, virtual factories, and large-scale worlds. Digital materials are crucial in this ecosystem as they provide accurate and consistent representations of physical properties, enabling realistic simulations and seamless integrations across various stages. So with open exchange standards such as MaterialX and OpenPBR, we can create ground truth digital assets that can be shared and utilized throughout the entire process lifecycle. So new in Kit 106.1 is support for MaterialX 138 and OpenPBR 0.5. This includes an improved first-class MaterialX integration with an updated material property panel and material graph editor. The new property panel displays MaterialX render contexts alongside other render subgraphs, allowing you to conveniently switch between them when making edits. And our graph editor now natively supports MaterialX nodes, allowing you to directly author and modify MTLX shade networks. Combined with non-destructive authoring via USD composition arcs in Omniverse, you're able to enhance imported material graphs by layering additional overrides into your MaterialX networks. As part of our commitment to Open Material Exchange, we've been working on, to build a new material library built upon the OpenPBR 1.1 standard. The library will be available to anyone, but we've seeded this collection with materials for our industrial, manufacturing, and product configuration partners to help ease them with their MaterialX adoption. Currently, we've added over 1,600 OpenPBR materials to this collection, and each material is packaged as USD with MaterialX 1.39 shade nodes. And so they'll be consumable in any MaterialX and USD-enabled application. So there's no requirement to use Omniverse. In terms of release date, we aim to make this available as soon as possible. Currently, a major focus for all the teams here today is a release version of OpenUSD that supports 139. At the moment, the ability to utilize 139 content is pretty limited. And so to address this, the various teams have been collaborating to align version numbers and ensure compatibility. So we're pretty optimistic that we'll see a compatible release soon, which will allow us all to update our software accordingly. Here are some examples of using our OpenPBR library on one of our product samples. And another benefit to Open Exchange with MaterialX and OpenPBR is that it provides us opportunities to integrate with other tools, such as NVIDIA inference microservices. So here we're applying OpenPBR materials using NVIDIA's USD Smart Materials NIM. USD Smart Materials is a cloud API that predicts and assigns materials to USD models through descriptive language rather than manual assignment. So in this example, we've defined a new material model called luxury handbag. And the description reads, a luxury handbag typically features a combination of high-end, durable, and aesthetically pleasing materials. It is usually a fashion accessory with a structured body, a handle for carrying, and various decorative and functional components such as rings, legs, locks, and sometimes a clochette for keys or decoration. So for industrial workflows, for example, that use CAD applications where there isn't really a material system, inference and material interoperability open many new opportunities for these industries to expand their pipelines. And because of the output from the NIM is standard USD and OpenPBR, the data can be modified in our material graph editor or any other USD application. Here, we're augmenting the material network output by our USD Smart Materials microservice, and new MaterialX nodes are non-destructively layered on top of the NIM shading graph through overrides to produce new combinations of materials for product configuration. All of this is possible and portable through MaterialX and OpenPBR. For future work, we believe that there's still a lot more to do with MaterialX. There are many things yet to be defined. So this year, NVIDIA proposed to the TSC a new hair BSDF based on the Chang paper, Practical and Controllable Hair and Fur Model for Production Path Tracing. We submitted a parameterization for the BSDF along with practical implementation for review. And there was great discussion and debate, and overall, it was an excellent example of partnership across multiple teams. The BSDF is not yet formalized, but we're hopeful we've reached broad consensus and that it'll be adopted soon. Soon we'll be proposing 2 additional nodes for consideration. The first is a retro-reflective BSDF. We've had a lot of requests from companies creating digital twins to add this to MADX. And the second is a hex tiling node for creating efficiently mapped infinite environments. Both these nodes are very well documented and in wide use, and so we'll be making a formal submission for review in the coming weeks. Lastly, we made some minor contributions to the new OpenPBR playground referencing. We updated that scene to the latest OpenPBR, as well as did some validation work to make sure it was compliant for release. If you're interested in learning more about AI and OpenUSD, we have a number of training labs at SIGGRAPH this year. Thank you very much for listening. And now I'll hand the presentation over to Nikola from Autodesk.
Thank you, Frankie. That was really impressive. Let me try to share. Hey, everyone. 1 second. Can you see my screen? Anyone figure it out? Yeah. So everyone, so my name is Nikola Milosevic. I'm a product manager for lighting, rendering, color management, and graphics in M&E division. Please check safe harbor statement. In short, some of the forward-looking statements you will hear during this presentation are not granting actual features or ability in the future releases. So please don't make any purchases decisions that are based on those type of statements. Today, we're going to talk about LookdevX, which is agnostic material authoring tool. It's integrated in Maya. And ultimate goal is to replace Hypershade and make sure that LookdevX is your home for look development. Currently, LookdevX is offering native support for USD and MaterialX material authoring. It's worth mentioning that LookdevX is Arnold supported and remains open rendering compliant. LookdevX is engineered for DCC portability, and currently within the Autodesk, our automotive colleagues from VRED are working on the LookdevX integration as we speak. 2024 was all about USD story, while highlight of 2025 was releasing of MaterialX native implementation. Starting in 2025, we'll be working on both data models simultaneously, try to keep them aligned and maintain the highest possible level of usability, which is going to be quite fun because 2 different data models. As I mentioned earlier, 2025 release brings native MaterialX workflows to life in Maya. In short, you'll be able to natively authoring MaterialX graphs and using LookdevX and then assigning them to Maya geometry. Current video demonstrates capacity to display Maya geometry and use the geometry within the same session, render them in viewport using MaterialX shaders, and later render them in M2A Arnold, utilizing MaterialX and Arnold shaders. And as you can see, we have quite good parity between the viewport and Arnold. Fairly simple shot, but anyway. Unifying different data type workflows was enabled by introducing multiple runtimes within LookdevX. One is done for USD, one for MaterialX, and then we introduce new design choices that can help you to facilitate your ability to work in more than one data model in the same session. So starting screen, tabs for data model, clear indication for nodes regarding the library source, and many other things. MaterialX document stack is introduced through Maya data framework, which is providing you features like exporting, importing, and referencing within .ma file structure. And then MaterialX document is introduced as MaterialX concept, where you can actually directly export import graphs as MTLX files to the disk. 2025 brings a lot of usability features and overall performance improvements. Regarding material authoring, now you can actually, with one click, promote and demote attributes to the input and output nodes or to the top of the material. That's one of the interesting feature from many. As I mentioned earlier, Arnold is seamlessly integrated into our system. The graphs are exposed through the MaterialX and the USD runtime. I think it's good to mention that Arnold supporting my MaterialX supplementary library. And regarding releases, we always highly recommend to utilize latest Arnold release for catching the latest features. Third-party renders can express their graphs using LookdevX tech through MaterialX. And what you see on the screen right now, it's a current example of render using viewport, Arnold, and V-Ray using exactly the same one MaterialX graph. Regarding the future stuff, the 2025.1 release already delivers some interesting stuff like implementation of hide input nodes, which is going to help you to simplify graph complexity. Node library is introduced as another modern usability feature that will improve your daily life in creating the graphs. And this update .1 already added support for the volume shaders in MaterialX data model. Viewport support for Arnold materials is expressed through MaterialX standard library nodes. It ships with the Arnold core, and in phase 1 we added standard surface support, image node, add node, multiply, subtract, and some of the math nodes. For the upcoming stuff, for the upcoming releases, ramp is going to be added as the fully functional node with many enabled workflows that will undergo for more updates in upcoming releases. The smart connection feature will greatly improve usability by automatically connecting incompatible ports by using hidden conversion nodes. And then we expose material binding and inheritance in Attribute Editor, which is pretty much USD feature that is enabling inspecting and controlling USD material binding for any selected prim in the stage. And regarding the viewport support for Arnold materials, we will add support for a few more extra nodes. And on top of this, we will introduce pass-through function for node-supported nodes and attributes with a clear indication in the graph what they are. Currently in work is a publishing workflow where you'll be able to publish your MaterialX shaders, definitions, and materials creations within your custom library or libraries. Then we will reinforce interop between MaterialX and USD models by improving USD referencing MaterialX experience. And after that, we will work on relative paths and and component tags support for MaterialX in Maya. From 2025, OpenPBR was accessible through MaterialX within Arnold library, but now it's also available in beta form through LookdevX and Maya Hypershade for those ones who's interested in experimenting with the new shading model. As I mentioned before by Adrien, our next step will involve incorporating OpenPBR as the default material for both Maya and 3ds Max. Hydra remains as a central focus for many Autodesk teams. This is ongoing effort that aligns with Autodesk long-term vision where Storm via Hydra will serve us as a company viewport solution. This video showcasing pretty much the Arnold, Storm, Maya viewport rendering Maya and USD geometry using Arnold and MaterialX shaded graphs altered in LookdevX. It's pretty much like classical Hydra, multiple tails and multiple heads story. It's mentioned before, but it's some of our team's open source contribution highlights are the image node fixes that are enabling three-planar GLTF image, use the UV texture to be visible in Hydra and viewport, and the loading material graph optimization that includes smart shader generation fix where you generate only one shader instead of many anytime and is not possible. And this fix, again, is presented in this video, and it's improving overall loading the USD files. And recently, we delivered MaterialX OCIO plugin, which is enabling OCIO Nano or OCIO to be used on demand for color conversions for MaterialX graphs. Regarding the planned contributions, like ramp node is already included in community discussions. Conversion nodes, bias, and gain nodes are internally prepped, and a few more proposals are coming very shortly. Regarding AI-enabled workflows, our group is focused on texture generator model. Our solution is enabled for multiple service providers, currently working towards integration of Getty Images data model. Authentication will be done through the Autodesk SSO. And most importantly, API and examples will be provided, so you'll be able to build and integrate your own custom generated model based on your own data or data delivered by different providers. The current state of the texture generator will be soon available in Maya beta program. Exposed features include image extension, upscaling, image variations, painting in option, and many other standard functionalities known by the other texture generators. Thank you. And now we can move to Mihail Djurev from Kutz.
Thank you, Nikola. Hello, I'm Mihail Djurev from Kutz, and I'll present the MaterialX implementation in V-Ray. A few words about what V-Ray is. V-Ray is a ray tracing renderer that is very popular in several industries. It's widely used for architectural visualization, product design, and automotive visualization. And it's also used in the VFX and film industries, where V-Ray has won an Academy Award and an Emmy. To serve all of these use cases, we have integrations in a lot of different DCCs, for example, 3ds Max, Maya, and Houdini. All of those DCCs come with their own set of unique material and shading nodes. To support them, V-Ray has a plugin system that allows for native implementation of every node. In addition to that, users are able to code their own materials in a shading language such as GOSL, OSL, or MDL. When we talk about V-Ray, there are several different renderers available. We have V-Ray CPU, which has the full implementation of all V-Ray features. We also have V-Ray GPU, which has most of V-Ray's functionality implemented to run fast on GPUs. And finally, we have Vantage, which is a standalone application focused on hardware-accelerated ray tracing and real-time rendering. Supporting so many DCCs has its challenges, especially when we want to share assets with non-trivial material graphs. Every DCC has its own idea of what a good set of shading nodes or materials should be. Adding support for them has resulted in the accumulation of a lot of nodes over the years. Some of them exist to support specific node in a certain DCC. Another way we tackle this is by translating the native DCC nodes to one of our existing more general nodes. However, there are often subtle differences that prevent us from reusing an existing node. For example, we have more than 5 noise implementations for different noise types, and that makes exporting hard. But it's still easy in comparison to importing, which is much harder. Whenever we want to import from V-Ray to a DCC, we have to try to map quite a large set of nodes to the limited set of nodes that the DCC supports. Of course, we can always have universal placeholder nodes with generated UI, but the user experience isn't that good in those cases, and not all DCCs support that. We've come to the conclusion that the best way to ensure compatibility, even within V-Ray integrations, is to use a restricted set of nodes. For example, this is the approach we use for Chaos Cosmos, our asset library, where we use a well-defined subset of our shading nodes. MaterialX is similar in this regard, since it provides a set of nodes that is restricted, yet can be used to create a variety of shaders. It's also not specific to a renderer, so that makes it well suited for an interchange format. Additionally, it's very useful that nodes in MaterialX can be defined as node graph implementations, so the basic set of nodes can be kept relatively small for the integrators like us. So how did we integrate MaterialX in V-Ray? In our experience, writing render integrations is hard. It's comparable to writing a whole renderer in complexity. We have many integrations, and because of that, we wanted to make sure that the translation process is as easy as possible. We wanted to have a native V-Ray node for each MaterialX node with matching parameter names and types. That way, translation becomes trivial. We could have used an intermediate language like OSL or MDL, but that would have increased the complexity and would have made debugging harder. Additionally, having native nodes eliminates the need for recompiling shaders, which can improve interactivity. And that is crucial for good UX when doing look development. So, although relatively small, the MaterialX set of nodes contains around 700 nodes if we count the different type signatures separately. To get around this, our developers figured out we can use code generation. With the help of the MaterialX SDK, we generated stubs for all of the nodes. Whenever possible, we mapped existing V-Ray nodes to MaterialX ones. The translation happens internally, so V-Ray integrations only see the MaterialX interface. We even went one step further, as MaterialX nodes can be auto-generated from node graph definitions. The rest of the nodes were manually implemented. For more complex cases, especially for procedural textures such as noise, we generated OSL or MDL code and translated it to compile as C++. This ensures that the nodes are as standard compliant as possible. Currently, the MaterialX support is available in V-Ray 6.2 and later versions. We support roughly 90% of the MaterialX nodes, which cover the vast majority of use cases out there. In the future, apart from reaching 100% of course, we have several things planned. We are working on OpenPBR support for our next major release. We are also experimenting with a node graph definition of the V-Ray material. It would allow people who already have assets created with V-Ray to render them elsewhere. And finally, we are working on supporting MaterialX in Vantage. Here is a sneak peek of a work-in-progress build that shows Vantage running as a Houdini viewport rendering a scene with MaterialX. And with this, I'm handing it over to Chris from SideFX.
Thanks, Mihail. Hi, everyone. I'm Chris from SideFX, and I'm going to talk just a couple of minutes about MaterialX and Houdini 20.5 that was just released a few weeks ago. Don't you just love those timely coughs? Sorry about that if I missed the mic mute. All right, so today I'm going to give a quick overview of MaterialX and Houdini, and then cover two new features that we are excited about in Houdini 20.5 and how they relate to MaterialX. As an overview, MaterialX first landed in Houdini in version 19, and a lot of the motivation came from Karma XPU, this new render delegate that we've been working on, because we wanted to simplify building materials for both the Karma CPU delegate and the Karma XPU delegate. And so MaterialX seemed like the right approach to us. Our adoption is a little different than some renderers and some support. We kind of treat MaterialX as a specification, and we don't use code gen. So we just re-implement or implement the MaterialX nodes in the renderers so that they just work as expected. We are also very heavily emphasizing the USD encoded MaterialX shaders. We do have some support for reading and writing MaterialX graphs, node graphs, and documents, and we use that for building some shaders, but for the most part, our workflows are USD focused. Whenever there's something that MaterialX can't yet do, or is still in progress in discussions in the community, we'll implement Karma specific nodes that can interop seamlessly. Currently, Houdini 20.5 supports MaterialX 138.10 and ships with USD 2403. And here's a little bit of a history of previous USD and MaterialX versions, as well as VFX platforms versions. And yeah, that's where we're at as far as the library versions go. So first new feature, quick surface material. This is a USD encoded MaterialX network built around standard surface that provides a simpler experience for artists to build materials in Solaris. So the materials public interface has all the controls that the artists would interact with for setting colors, choosing texture maps, and the underlying graph is not editable or not edited by default, which means that performance is pretty fast because we don't have to recompile shaders on the GPU for changing graph topologies. As I said, it's currently built around the standard surface, but as Adrien gave a sneak peek, we're excited about OpenPBR in Karma, and so we expect to build around OpenPBR in the future. As I mentioned, this is all USD, so what we're doing is we have a USD layer that ships in Houdini, and we just reference that off of from your Houdini install directory, and it's instanceable by default, so it's pretty efficient. Even when you specialize additional materials off of it, there's still a lot of efficiency gains that happen because of that. Now, the second feature, which integrates and relates to quick surface materials, Copernicus. Some of you, if you caught the launch or if you checked out the new version of Houdini, Copernicus is our new image processing engine, and it adds a new old COP context. COP has been around, but COP 2 was the old COPs and COP is the new COPs, so it's not confusing at all, right? No. We're excited about this to be able to do some cool texture and image processing. It builds on OpenCL and OpenFX. We like embracing these open standards, and it integrates with MaterialX in a simple way. Currently, we just use the standard texture nodes, so you can use a MaterialX image node and use this op syntax to refer to a Copernicus node live in your Houdini session. And as you can see in the video, they can update live, both in the Copernicus viewer and also through the shading graph and through your renderer live in Houdini. Because this quick surface material is built around USD and USD MaterialX, it should work with any render delegate. This live Copernicus support should work with, this is a feature that's been used before Solaris, and so renderers that already had Houdini plugins might already have most of what's needed for the live Copernicus textures to just interactively update. But we're really excited about Copernicus and MaterialX and the where things are at now, but we're really excited about the future. And it's been great to collaborate with the community and to see not just today, but other examples of what everyone's been doing around MaterialX. And we're grateful for everybody's hard work and contributions. And with that, we'll pass it back to Jonathan.
Great. Thanks so much, everyone. Let's see, I'll put a question and answer slide up now just to make it official. And we already have a few questions in the Q&A section. If you have additional questions, go ahead and post them in the Q&A rather than the chat so that we can keep track of them the most easily. I'll address one from Joao, which is the question, will the slides of all presentations be available somewhere? Yes, we'll be posting that pretty shortly after this event. We'll also be, there will be a YouTube video of the entire event as well. That'll come a little bit later that the ASWF will post. I see a question from John, and this is to Autodesk. This would be for Nikola. Could you talk more on LookdevX and MaterialX in regard to being renderer agnostic? such as advancements that would support artists not using Arnold. Nikola, if you wanted to take that one, go ahead.
Yeah, I mean, it's like, LookdevX is pretty much like supporting any kind of open source like efforts, like so you don't need to use Arnold. You definitely can use anything that is actually supporting MaterialX or USD that is actually part of the Maya in this case, and in the future is going to be part of the any kind of other DCC. So it's quite obvious why agnostic approach is actually, which is quite hard, is not easy, and it takes us a lot of time to actually deliver it in properly, is the right way of doing it. So anyway, in short.
That makes sense. Thanks, Nikola. Yeah, there's an additional question we have from Sven. Is there a plan to integrate MaterialX and OpenPBR to Siemens software solutions? For example, NX, Team Center Visualization. That's a little bit outside of my knowledge base, but did anyone want to speak to that in our group of presenters today? I think the answer may be we don't yet know. But that sounds like a good question, and that I would encourage you to bring that up in the MaterialX channel of the ASWF Slack, because that has now some 700-800 people from all different industries, and there's likely to be someone in that group that will have a sense. Let's see. We have a Houdini question from Oliver. In Houdini, there is the .node hack to access a few karma features. Are there plans to translate this to proper node definitions? I'll hand that over to
.node hack. That sounds like a band. .node hack, or maybe a cool album. We are working to some of these features that are karma specific that you would access through the .nodes. We would like to not have to use the .node as much as possible. Just have if it is karma only, just have a karma node dedicated to it, or if it's something that's worthwhile for MaterialX as a whole, work to upstream that with the project. So ideally, those .node hacks will be diminishing with each release of Houdini and MaterialX. But please, log RFEs either with us or also on GitHub with the MaterialX group if there are things that would be good to bring before the wider community.
Thanks, Chris. And we're getting pretty close to time, but I see a question from Joao that I think will be on a lot of people's minds. So I think it's worthwhile to address, and I can maybe take this one. The question is, have there been any recent developments about supporting MaterialX 1.39 in USD? So that's a huge collaborative effort involving, I think, all of the teams that presented here today. And that's something that we're all working towards. We don't yet have a timeline for that, but it's obviously an important hurdle that we'll need to surmount in order to have access to OpenPBR in all of the USD integrations in the industry. We are very optimistic that this is something achievable, but there are some steps along that path that we'll need to take. You can see some pull requests on the USD GitHub that relate to that directly. There's some work from Apple and Autodesk that relates to this strongly. As with one of the questions earlier, you can follow along on the progress of this on the ASWF Slack, both in the MaterialX channel and maybe more specifically in the USD MaterialX channel. We have a dedicated channel just for that, and there's a lot of discussion of these questions there. I think since we're out of time and that was the last of our questions, maybe we can wrap it up here. Thanks so much to all the presenters today. This was an amazing collection of talks. I'll hand it over to Emily if you wanted to say any parting thoughts.
No, just a reminder that we have more virtual town halls coming up this afternoon and tomorrow and Thursday. And also, if you haven't already registered for open source days on Sunday, we'll be in Denver and also virtual. So make sure to go ahead and register, and looking forward to seeing many of you there.
Fantastic. Thanks again, everyone. And yeah, we'll see you in the Slack and in the mailing list, and we hope to have more people collaborating with us on Dev Days this year. Take care, everyone.
Thank you. Thank you. Bye.
Thanks.
Thank you.